Is there a home field advantage in baseball? In 2007, the home team won 54.26% of 2,431 games. Is this due to natural sampling variability, or is it evidence that there really is a home field advantage? So, we are going to assume there is no advantage. P is going to be the proportion of games won. So we're assuming there's no advantage, which means P is going to be 0.5. Okay, it's like 50-50. So our null hypothesis is that P is equal to 0.5 or 0.50. Our alternative hypothesis, and sometimes just so you know, I'll write it with a capital A or a lowercase a, it doesn't matter. Either one is fine. Is that so we're trying to show that there really is a home field advantage, which would mean that the home team wins more often, so we're looking at P is greater than 0.5 for this scenario. So that would be the hypothesis part. And a lot of times, the more we do it, we'll get to where like we're just writing the null and the alternative, not the like stuff prior to it.
Right.
If that makes sense. All right, so model. So we're going to look at our conditions. All right, so independence condition. What do we think?
Yes.
Yeah. Most likely one season is similar to another, but like one doesn't affect another, if that makes sense. Randomization.
I would say so. Yeah.
Maybe like the randomization from like them playing different teams each time.
Yeah, it's not necessarily random because the schedule is set and you have to
Yeah.
play certain people, but it is like representative of that in the sense because games should represent like overall a variety of
So
teams.
it's like a representative sample.
Yeah, so not randomly selected necessarily. Because like they have to play so many people in their conference, but then also like, you know, the league winners from the year before and you know all that stuff.
It just says the home team. In 2007, the home team.
What is the
Which
home team?
They're saying all of them,
Yeah.
all of baseball.
Them? Oh, okay.
That's why it's telling you how many games.
Oh, okay.
Because what is
Oh,
it?
yeah.
106.
That's a lot
I
of
didn't
games.
think about that.
Because 162 games roughly is regular season games is how many each baseball team plays.
That's a lot of games.
162.
Why did they?
That's why you
How long is
play-
baseball season?
From April to September, but they play every day with like a day off here and there.
How did they get
They
around
play like
that?
3 days back to back at home, and then they might have a travel day, and then they play away, or they might play at home back to back to back. Like it just depends.
That's insane.
That's
How many
what you have to-
rotation pitchers are there in the rotation?
Usually 5 starters. So.
Okay.
But anyway, so yes, that makes that number make a little more sense to you now, probably. And you could assume that about half of those games are played at home and about half are away. Give or take probably 5 to 10 for each team. That might have been helpful information before we started this question for me to inform you of.
It's okay.
I never think about what people do and don't already know about sports and cards and
I don't watch a lot of baseball. But
I watch it in like September when it matters.
I prefer
Leading into the playoffs. Game should be reasonably represented. Josh can't.
I mean, I think I can ice skate. It's been years though, so
I can't.
I could
I
probably
can't.
pick it up again.
So
How
a
many
lot of
times- how
hockey
many times
players
have
are
you
missing a
iced
lot of teeth. I don't know what that.
Well, I mean,
Oh.
if you get a puck to
I
the
already
face.
fit that bill.
Oh.
Gotta be
right.
willing to fight. That's what
Well,
the
you're not
fans go
missing a
for.
lot. You're only missing like one or two.
Yeah.
All right, 10% condition. Is this less than 10% of all games ever played?
Probably.
Yes,
yeah.
ever played?
I'm thinking so.
Gonna say.
I feel like baseball is like the oldest sport in this nation.
Yeah, Kenny's been watching every night this it's not like a documentary of baseball, but it's like the greatest players at each position, like the 10 greatest players and then like the 10 best teams over time, like, you know, would the 2004 Yankees beat the 2021 Braves, like things like that. And I'm just like, this is too
I
much.
couldn't.
Yeah, I'm like, are you going to be watching that? Because I'm going to watch something on my iPad if that's what you're watching. And he's like, no, we can watch something together. He was like, you don't like this? And I was like, that's boring to me. I don't want to watch that. I don't care that much.
I would watch a baseball game. I would not watch it. That.
Yeah.
No, he's back.
Stop Christian.
All right, success, failure. N times P. So 2431 times 0.5. And this is also going to be equal to NQ because, you know, they're equal percentages.
Alright.
Well, I already know that's higher than 10.
Yeah.
Definitely.
When it's something you know like that, you don't necessarily have to actually write out the number, but we will for the sake of practice.
Maybe they want you to write that out on the exam, and they'll take points off if you don't. I think that would be silly.
All right, so this meets the conditions.
So we don't need to do an N times Q for that one?
It's the same.
The same thing. That's what
Wee.
you said.
No.
Where you been, huh?
Oh, I don't even know.
All right, this meets the conditions for the normal model.
Just got late.
Oh my.
Just give it a second. Used one prop z-test. It's because I'm writing on the side, but I have to like hold it over to the side for y'all to be able to see it.
You're offended at
You should be offended. I hit my arm.
All right, mechanics. So this is actually going through and kind of doing the work for the problem. So we need to find mu, which is P0, which is 0.5, and we're getting that from the null. The standard deviation of p hat is the square root of P0 Q0 over n, or the square root of 0.5 times 0.5 over 2,431.
How far up you want us to go?
5.
1, 0, 1, 0, 1, 4.
Okay.
Have you guys got your stuff?
I'm not done everything I sent her to.
I think I've got most things.
I need to order a battery pack for my phone.
I still have a piece of it.
Battery pack.
I got a one piece of it.
I got a
It's no stuff.
great. So I bought a battery pack on.
I got a
Sky.
Coke
We got a pretty good deal
boot.
on it. It's also
That's good
a
enough.
lot. It's like 2,000.
I'm not
got
Mega amps.
Mega amps.
what?
Mega amp.
I said
He says
watts.
milliwatts. That would not be very much.
I think I'm bringing a power bank like charger thingy, but like I feel like I'm not gonna be on my phone that much. So probably, like,
I
take
will say the
pictures
only
and
thing I'm
stuff.
gonna say is because it's cold and we're outside a lot, your phone will die faster. That's the main reason. But I'm also bringing it for the GoPro because I'm gonna bring the GoPro with
Where
us.
do you put your phone when you're skiing? Just in your pocket?
I have pockets on my ski pants
I also have
Your
pockets on my
phone dies
ski
Oh my
faster.
goodness.
in the cold.
Why?
My phone
So-
dies faster when we travel.
My
Is that a thing?
hmm
Okay.
I just got like snow pants for like senior trip or whatnot.
Mm-hmm.
But I was keeping it in the closet. But we went to church like 2 Sundays ago, and somehow Mochi got stuck in the closet while we were gone for like
Oh dear.
5 hours. So we just like started like eating everything in there.
Yeah,
So-
your snow pants?
There's a hole in my snow pants now.
That's crazy.
That's not funny, but that's funny. Hello, everybody.
What y'all doing?
What do you think
It
we're
only
doing?
went through like the first
He's
layer.
telling us about how Mochi ate his snow
It
pants.
only went through the first layer,
I just thought of
so
this
like
and
I
I
think
just
I
wanted
should
to
still
show
be
you.
good to wear it. So
It just
if I'm wearing
it's
those pants and
literally
y'all
me.
see that,
even care.
you-
Just
Me
give
and
us a
you
good
care about
ski
yesterday.
accident story with it.
Me even care. This is me yesterday on the bench.
wait, let me see. Yeah.
So I kind of yelled at my teammates
Yeah.
yesterday.
On the bench?
I didn't say that word, but I basically was like, "Why?" Okay, my parents heard me too because it was quiet in the gym. It was
Everyone
absolutely
heard you,
silent, and I was screaming at my teammates on the bench. I was like, "Why are you guys behind the defender when someone shoots? Like Peyton just shot, you're behind the defender. Why can't you get the rebound because you're behind them? So get in front of them." And I was so mad. Kristen let me.
Yeah,
She left me. She was like, "Okay." Like that's all she said.
That was only one person that was mad.
Well, you know, everything I do.
That sounds about right. You don't even have to say who. I know exactly.
The correct number is 25,000 milliamps.
Oh.
Is that what MAH stands for?
Yeah.
Okay.
Wait, what?
Okay, one prop Z test.
I was like, what are you doing?
So you need the one prop Z test on your
Not one minus.
calculator.
Not one.
Oh, not bars. Stacks.
Oh yeah, I keep on pressing bars too.
I know. I keep trying to do second bars.
Yeah.
So this is what it should look like typed in.
Are those things getting multiplied?
This part is, yeah. So you can either pre-multiply them or you can just let it do it for you. If you type it in and say, like, hit the multiply button, it'll do it for you. So there's no need to do it separately.
Bird. No stats.
Oh, thanks.
What color should I make it?
Purple.
Color.
That was so aggressive.
Well, your calculator may be a bit primitive.
But what is it doing to... Oh, I know what it's doing. Never mind.
Is it gonna graph?
Disregard. Yeah. Well, it's going to give you a graph.
So the x value is those two multiplied terms?
Yes. Because this is the number for our specific situation.
Wait, where we get the point? 5426.
That's
Oh.
you know, that thingy.
I forgot. I'm sorry.
So where did the second 2,431 come from?
It's the value that you've got to type in.
I got an ebb.
Wait.
How
How do you multiply the two things? Like, do you have to
0.5426 times 242.
No, like you have to multiply that and then plug it in.
You can just do it on there and it will
I got it
automatically
here.
find it for you.
Oh.
Wait, so that's the x value.
Hold on.
Oh, I understand now.
I'm going to try.
Oh, it did. That's cool. Sorry.
No,
Did anybody else?
And I have to pick the greater.
we all-
Oh, yeah, it does just do that. Calculate or draw?
Calculate.
Okay, calculate. Oh, yeah, I also got an error.
Hmm.
So
Whoa, not that option. That was not it. Oh, wait. I forgot. So if you choose to multiply it within, you have to delete off the decimals. It's got to be a whole number. I forgot about that part.
So,
That was my
so it
bad.
has to be the
So like when you're done, it needs to be this number. So like it was 1319.6727, or you know what I mean, like some obnoxious decimal.
Okay.
You have to delete the decimals off and it does it. I forgot about that part. Got to be a whole number there. So we're looking for the
number now.
yeah.
Oh, I
So
got a
we're
bunch of numbers.
looking for the z value. So what is z?
4.20.
4.20. And just for a visual for you, I'm not sure if we hit the draw button, this might do it, but we're saying that 0.5 is here, and we're trying to see if basically 0.54 over here is unusual.
Ooh. It does do things. Makes this nice little hill.
So the probability then of z being greater than or equal to 4.20 is what? So what's the p-value there? Or not the p-hat, but like the other p, which is probability.
1.35.
Finish it.
1.35
Just look at the end.
times 10 to the negative fifth.
So what is it? Approximately
Is it 0?
0.
Oh.
Because this would be 0.00001. So this is the p-value that we would be looking for to determine high or low. Okay? So our conclusion to this is going to be quite long, so don't write too big. A p-value of less than 0.00001, because that's what it is for this problem, says that if there was no home field advantage,
I feel like I'm writing too small.
and the true proportion of home wins was p is equal to 0.5, then an observed value of 0.5426 or larger would occur less than I'm going to say 1/1000th, but it's going to technically be less than that, but it is less than that number, so it's fine. Less than 1/1000th of the time, basically. So then here's where we really get to the real conclusion for this specific problem and what they would be looking for. That's kind of just an explanation. A p-value that small would cause me to reject the null So notice it's a small p-value, so we reject the null hypothesis. And it shows that there appears to be enough evidence of home field advantage. So that enough evidence of home field advantage is a sufficient amount of putting it in context.
Wait, so home field. So there is a home field advantage, is what it's saying?
Yes. Because we rejected the null said that there was no advantage. So since we reject it, then there would be an advantage. If we failed to reject, then it would be opposite. But so then we won't do this on all of them, but if we create a 95% confidence interval with this data, we get, somebody find that interval, which is for the true P of home team wins. Or I can do it.
How do I find
I mean, I got
One prob
something.
Z interval.
that? One prop to
Like, I'm not sure if I put in the right things, but
What'd
I
you
got
get?
0.52. Do you want me to go out any farther than that?
Go 3.
0.523 and 0.562.
Yep. So that would be the interval for the true P of the home team wins.
How do you find that again?
One prop Z interval. Just the stuff from the last section. All right, we're gonna stop there because we're not far from the bell ringing, and